the crystal structure. Now let's move into slowly how these X-rays are produced. Fundamentally, the X-rays are produced when high energetic electron beam strike a metal target. So that is the basic. When high energetic electron beams hit and penetrate metal targets, specifically having high atomic numbers, X-rays are produced. Now, the equipment which is used for X-ray production, it is known as Coolidge tube. Now, this modern Coolidge tube mainly consists of a source of electron, because we need electrons, and then we have a effective means of accelerating electrons. Just now I said X-rays are produced when high energetic electron beams strike metal targets, specifically of high atomic numbers. So in X-ray production equipment we need basically two things, that is a source of electron and effective means of accelerating these electrons. The modern Coolidge tube schematic sketch is shown on the screen, and let's try to understand how these X-rays are produced using this equipment which is known as Coolidge tube. Now the Coolidge tube, which was designed by originally William Conrad Roentgen, it was very simple in design, but the modern day Coolidge tube is very complicated and it has really gone drastic changes in its design. But as a student of 12th standard, we are not interested into design details, we are just interested into basics, that how X-rays are produced. Now here, the modern day Coolidge tube consists of 5 main parts. The one is electron gun, then we have a target, the third one is we have a source of high potential difference, and we have a vacuum system, and then a cooling system. These are the 5 main components of any modern day Coolidge tube. Now let's go slowly one by one. Now let's talk about electron gun. Now this electron gun acts as a source of electron. We need electrons to hit the metal target, which is the basic requirement of X-ray production. So this electron gun acts as a source of electron. Now the emission of electron from filament is based on thermionic emission of electron. This electron gun circuit is shown in the figure. Now in this circuit we have a control over the current, we can vary the current, we can control the heating effect. So we choose electron gun parameters such that electrons are emitted from it with negligible speed. We can play with the parameters. The basic thing is the phenomenon of emission of electron is based on thermionic emission. That means electrons are ejected from filament by application of heat. So we call it technically thermionic emission of electrons. So electron gun basically acts as a source of electron and it is based on thermionic emission. And the third point which is important is the electron gun parameters are so adjusted, that is the resistance, the current, the battery EMF, such that electrons are ejected from filament with negligible speed. Now from the chapter which we have taken up earlier, and it is photoelectric effect, there we make electrons eject by application of light and we call it photoelectric effect. And here we are ejecting electron by application of heat. Basically we have to overcome work function. So we know that work function is the minimum energy required to free electrons from metal bondage. So here to make electron eject from the filament, so our heating effect has to be such that we have to overcome work.